Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. We've recently launched our Patreon page, which can be found at cynicaldeveloper.com/Patreon. If you aren't familiar with Patreon, it's an easy way for those who are interested in this show to help out by simply pledging a small amount each month in sponsorship. Now that could be as little as $5 a month, which is about £3.80, or as much as you like. You will enable us to dedicate more time creating more content to help you, including videos, more blog posts, and even more shows. So if you can, head over to cynicaldeveloper.com/Patreon and get involved. In this episode, we'll be talking about Blazor with Jamie Taylor, and he's here to explain what all the fuss is about. Jamie is a full-stack .NET developer with a focus on web cross-platform. He lives and works in Leeds in the UK and has become the go-to guy for .NET Core at his current workplace. As some of you will be aware, Jamie's been on the podcast before, back on episode 8 and 62, where we talked about .NET Core. When he came on last time, he just started his own podcast, which some of you will undoubtedly enjoy, and it's called The Waffling Taylors, and it's a gaming podcast. Since then, I don't know how, but he has started several other podcasts. The .NET Core podcast, which is obviously about .NET Core, devotku, which is about anime, and more recently, the Ask a Brit podcast. And that is a lot of podcasts to start taking on, as well as starring on other people's podcasts, going off and doing talks, and a million other things. But it is good to have you back on the show, Jamie.
Yeah, it's great to be back, James. I'm a bit like a bad smell. You can't get rid of me.
Yeah, I was saying that to someone the other day. You just keep popping up everywhere, and it's getting irritating. Stop it.
One of these days I'll reach world domination somehow.
Yeah. You will get into that top 5 podcast spot, even if you have to make enough podcasts that you actually take up 99% of the podcast listings.
That's essentially the plan, yeah.
Going for a volume rather than quality approach.
That's it. That's my entire professional career.
Quantity over quality.
That's it.
Awesome. So we're not here to talk about your podcast prowess. We're here to talk about this odd technology called Blazor that people seem to be absolutely raving about at the moment. I've not looked at it really. I've listened to a few people talk about it, but for everybody out there, what is Blazor?
Okay, so Blazor it's a wonderful technology, and the name is a portmanteau word. So it's a combination of two words. It's a combination of browser and Razor. So the idea is you're going to be able to use. Originally, it was Razor pages inside of your browser. I can go into what that means in a moment, but essentially the TLDR of what Blazor is you can now run .NET applications, your .NET code, inside of the browser.
Okay, so that differs slightly from ASP.NET, where stuff is rendered on the server and the output from that render is served up to the user.
Exactly, yeah. So ASP.NET and ASP.NET Core they use a thing called the Razor templating engine. So you can partially write HTML and use a little bit of C# or whatever .NET framework, .NET Core language you want to fill in some gaps. So you can have a C# for each to help you fill in a table, for instance. But yeah, so that entirely. What you do is you put the Razor file through the Razor rendering engine, and out pops some HTML, and you throw that down the pipe towards the browser, and the browser will render that HTML. Whereas Blazor is you take all of your code and your Razor syntax and all that kind of stuff and put it into the browser and have the browser do all of the work for you.
Right, okay. That's... It's a bit of an odd technology, I think, because it's not something that I would have thought. Do you know what I really need is something like this. So, where did it come from?
Okay, so back in so this is based on the knowledge I put together for a talk I gave at Umbraco UK Festival. But back in 2010, there was a GitHub repo called .NET Anywhere, and the idea was to try and get .NET Framework, as it was at the time, running inside the browser using at the time, very brand new technology called WebAssembly, which hadn't been fully ratified yet. So WebAssembly is a way of running binary code inside the browser. So what you do, the idea is you take some C or C# or whatever code, put it through a transpiler, which takes it from one language into another language, and at the other end pops a binary with a WASM extension on it, and that's your WebAssembly file. And the experiment went largely nowhere. And then in about 2014, Steve Sanderson, one of the folks who works at Microsoft and the inventor of Knockout.js, happened upon this Git repo and went, oh, I think I can do something with this, what with him being on the team and stuff. And then, it's kind of sort of flown from there, really.
All right, okay. So, what are the real benefits to having everything render in the browser rather than render on the server?
Okay, so I think the first benefit, which I think will make a lot of devs, at least web devs, happy, is you no longer have to have a mapping from a C# object to, say, a JavaScript object or a TypeScript object or something in Angular or Vue. So, your C# object on the server, you would traditionally serialize those and send those down the wire and then deserialize it at the other end into a TypeScript or a JavaScript object and hope that all the properties match. Or in the case of TypeScript, you have at least some of the properties and you may have some other properties, you don't know. Whereas with Blazor, you're literally taking those C# objects and putting them in that .NET compiled code into the browser, so you're no longer having to translate as the response from your API to your view model, because your view model is the response from the API, if that makes sense.
Yeah, sure. So it's because you're not really leaving your application as you do now with sending stuff up and down the wire to and from the browser. So there's none of that interop stuff going on.
Definitely. And the other one, I guess, is speed as well. So, let's be honest, there's been a lot of work put into JavaScript engines as of late to make them faster. Or if you're a certain big company, you give up and rebrand your browser to use someone else's JavaScript engine. But, there's been a lot of work put into that. But JavaScript will never, beat binary sort of assembly level speed, the actual code that's used out on the processor. So the idea is that if you can convert all of your apps into WebAssembly and have it run at native speed on the browser, then you've got that massive speed boost. And because WebAssembly is a browser technology, it's instantly cross-platform. So you've got iOS devices, Android devices, and desktops all can run the exact same code.
Okay. So, if this is an application that is running in the browser, isn't that a lot of data, a lot of large files to send down to the client, at least initially?
Definitely, yeah. So just if I can step back a bit, I can explain how the whole application gets sent to your browser. So
yeah, sure.
Yeah. So what happens is you put in a request for, say, Blazor, which is an app that I built in Blazor that uses all of these techniques. What happens is your browser receives some HTML. The HTML contains a link to a single JavaScript file. That JavaScript file bootstraps a WebAssembly environment. That WebAssembly environment then downloads the entirety of Mono, or rather the entirety of a redacted set of Mono. So you don't get the whole Mono stack, you get most of it. And then from there, Mono then downloads your app, so your DLL, whatever, your code, and then it downloads all of your dependencies. So let's say you depend on Newtonsoft JSON, then yes, your app is going to have to pull down a 16 megabyte sized DLL just to run. But there's a couple of things there. Once it's cached in the browser, until the user clears the cache, it's always there. And the other thing is that the .NET Core tool specifically, .NET Framework doesn't have this, but .NET Core has this wonderful thing that when you compile, it will tree shake all of your dependencies. So tree shaking is essentially, it will look at your dependencies, decompile them, remove any methods and APIs and classes you aren't using, then recompile them with just the bits that you're using. So that 16 megabyte Newtonsoft JSON dependency, because you're only using deserialize of type T, becomes a couple of kilobytes.
Right. Okay. So you mentioned framework, you mentioned core, and you mentioned mono there. Is there support for the .NET framework and for core as well?
So essentially, Blazor will allow you to run anything that's .NET Standard compatible. So there's a lot of stuff that's not in .NET Standard, but it is in .NET Framework. The things that are in Framework that are not in Standard aren't supported, and there are certain things that you can't do in WebAssembly, because so WebAssembly sits on top of JavaScript. There are some things you can't do because JavaScript doesn't support it. So, for instance, you can't create an HTTP connection, but you can do an AJAX. You can go, hey, go to this thing, but you can't create a persisted HTTP client that you can send and receive data on. But you can go post this to the server, get this from the server, if you get what I mean. But other than that, as long as your code is .NET Standard compatible, there's nothing that says it can't be run in a Blazor environment. So one of the things that I did for Umbraco Festival UK was I used the headless Umbraco instance, their engine, to pull down content from a content management system that I put together using the Umbraco headless, and then I used the Umbraco .NET libraries in my .NET Core application inside of Blazor to render the entire content in my browser, to do the post to the server, to get the data back, to then automatically take that data and serialize it into a C# object, then use that C# object in the view. But that was all happening browser side. So as long as it's .NET Standard compatible, it will in quotes work in WebAssembly in Blazor.
Right. Okay. So you mentioned there that it was a subset of mono as well. With it being a subset, is that for any particular reason? It's sort of security based, that so you can't do certain things and alter the user's computer, or is it all still sandboxed safely and nicely in the browser?
So there's two things I'd like to talk about there. One is the security stuff. So in WebAssembly, you can only do what you can do in JavaScript. Now there's a huge caveat there, because JavaScript will allow you to get accelerometer and location data and capture the camera and capture the microphone and all these things. But technically, your browser will stop you from being able to capture that without prompting the user for access to that. So those little, you go onto a website these days and you get the little, this website wants to display notifications and this website wants to be able to download files and stuff like that. So those allow deny need to explicitly be set to allow on the website to be able to access those things. So WebAssembly will still only allow you to do what JavaScript is allowed to do within that browser instance. So yes, in that instance, it's still a walled garden. It's still pretty safe in that aspect. And the subset of mono thing is literally because there's a lot of things that mono does that JavaScript can't do. So there are things like file access and that HTTP client thing I was talking about earlier on, and maybe drawing arbitrary shapes on the screen using a pixel or something.
Yep.
These things, they don't need to be in the browser, so let's just take those out and do a build that is WebAssembly specific.
Sure. So because of all these caveats that are there that are enforced by JavaScript, is everything basically just transpiled C# into JavaScript, or are there parts of it that stay in the .NET world, and there's like communication between the browser and the server just to do those specific things?
Yeah. So anything that you send and receive from the server can be done if you want it to over signaler. So that can be done entirely in binary, talking from one .NET environment to another .NET environment, and everything's binary encoded, and all you see if you watch the pipe is just a stream of characters that make no sense because it's the binary representation of the C# object or the message that's being sent over.
Yep.
Whereas, sorry, I forgot what the other part of the question was. Oh, yes, about transpiling from C#.NET down to JavaScript.
Yep.
So part of it, so there is at the moment, at the time of recording, if your .NET code in the browser throws an exception, there'll be several layers of abstraction before you get the actual error bubbling up through JavaScript. So yeah, there is a little bit of transpiling from WebAssembly to JavaScript, but that's just because of the way that WebAssembly works at the moment. But once WebAssembly is up and running, it's running natively on your processor through the browser.
Okay.
So the error handling does go back through JavaScript, but everything else is straight to the processor and back up, if that makes sense.
Okay. Yeah. So you mentioned as well that this was cross-platform because it's using mono. Is that 100% cross-platform, that it's going to work on all mobile devices, all desktop devices, regardless of what creed, color, inclination that browser may be?
So essentially, if your browser supports WebAssembly, then it will be able to do Blazor stuff. Whether that's 100% of everything that Blazor can do or not will depend explicitly on the type of browser that you're using. If you're using Chrome or Firefox, then the chances are it's pretty high that you will be, whatever you want to do will be supported in the browser, simply because they were like the first to adopt WebAssembly and say, yes, this is definitely a thing that we can do, and we have full binary compatibility with the WebAssembly standard. Unfortunately, as is the way with a few of these things, Edge did fall behind initially, but has caught up. There is support in IE 11 through a JavaScript shim to load some stuff in. And as far as I'm aware, Safari supports it in that there's bony quotes around that, in that some things work and some things don't. I'll get the link for the show notes, I guess, but if you check on Can I Use and look for WebAssembly, then you'll get a breakdown of which browsers support it and which browsers don't support it. But yeah, essentially, if it's based on Chromium or whatever Firefox call their engine, I think it's Quantum, then you've pretty much got 100% binary compatibility.
Sure. So you do have to be aware that this isn't going to be supported possibly by every user that comes to your system. So it's something to be aware of, where you may have written your .NET applications previously and it was all dealt with by your server. That's fine, but now you're trying to dish this out to the client. You've got to be aware that some stuff may not work.
Well, I mean, I'll just caveat that with so there are two different rendering. I don't want to say systems, but there are two different ways to render Blazor. One is client-side Blazor, which is what we've talked about completely all the way through so far, which is load your .NET code into the browser and have the browser do all the things. And there's a server-side version, which the difference there is in the client side, you load the HTML, load some JavaScript, it then bootstraps a mono, and then loads your app. Whereas server-side rendering is your web application is an incredibly thin layer. It's just some JavaScript, maybe a little styling to make it look nice, but then the JavaScript makes a signaler connection back to the server, and the server does all of that rendering for you. So it does all of the updating of the DOM and figuring out what needs to be changed. And what happens is, say the user clicks a button to display a form, You click the button click event is then sent back to the server. The server does all of the figuring out of the DOM changes that need to be done, calculates a delta, so just those few things that need to change on the client, sends those tiny changes back down the pipe to the client. Those tiny changes are then applied to the DOM, so that modal is drawn and maybe a graph is inserted or something, and then that happens on the browser. So if you don't have full support at the client side, you can swap to the server side rendering method, but you will need a persistent connection between the client and the server to be able to do it.
Sure.
So they've kind of thought of the two ways in which this could work, and they've kind of come up against that. What if someone is legitimately using IE9 because, say, they're on an enterprise connection and maybe their policies state that they need to use Internet Explorer 9? Well, how do we enable this? Well, how about we do all the heavy lifting on the server and just literally send those small DOM changes through to the client?
Cool. So it's almost polyfilling itself to some extent there.
Pretty much, yeah. Pretty much.
Nice. So hosting a .NET website previously, you would have to have Windows servers before the likes of .NET Core came along. Is that still the case, that you need a server that's going to be able to do something with .NET in whichever flavor you're using?
Yeah, essentially. Excuse me. Essentially, yes. You still need ASP.NET Core to host all of the files and to set up that initial, here are all the things that you are going to need browser, even if it's the client-side rendering model that we discussed earlier on. ASP.NET Core still needs to throw those files up there. So you're going to need something that can run ASP.NET Core on the server. Now, whether that's ASP.NET Core on top of .NET Framework, which is still supported so long as you're ASP.NET Core 2.2 or 2.1, or whether that's ASP.NET Core being served by .NET Core, which is supported pretty much indefinitely, or whether that's some kind of hybrid or whatever it is that you're doing, as long as you still need a server side to be able to sort of bootstrap that initial setup and send up the files that need to be sent, because the Blazor engine at the server side will tell your client side where to go to get the mono WebAssembly binary and where to get any JavaScript shims that it needs and all that kind of stuff.
Sure. So that burst the bubble for a few people out there that were rubbing their hands in glee, thinking, great, I can now get my .NET websites running for free on some of these static website hosting platforms. You know, you still unfortunately need to be able to run .NET Core.
Mm-hmm.
Okay, so is there any examples where you could see this being used in a real world development, or is it just going to be another one of these cool toy projects? Because it sounds really cool, but I'm sort of struggling to think of any real place that I would think that this would be a benefit to me over what we're currently used to.
Okay, so some of the sort of cool toy applications that I've seen, such as there's a version of Tetris that runs in Blazor, and I think it's called Bletris. That's a cool toy. PokeBlazor, something that I built, is a cool toy. And yeah, so far they've all been sort of cool toy. Look at this cool piece of technology. And if I'm honest, I can see maybe a reporting dashboard. So let's say you're in a development company and you want to see the status of all of your apps in the wild. You could maybe have a client-side rendered Blazor application that talks to a bunch of API endpoints to get the health statuses for all of your apps. Or maybe you could have a server-side rendered application sat on a thin client that just polls back to the server every half an hour. What are the statuses of all of the web apps? So that could work. Or perhaps if you're working out in the field, and say you're literally working out in a field, and you're doing something and you need access to an application on your phone, you could then use Blazor client side before you leave the office to download the app and get it all up and running. And then when you're out in the field and you don't have a great internet connection, you can do whatever you need to do. And then as you come back in and get onto the Wi-Fi, you can hit submit and have all of your stuff submitted. That could work without having to use any kind of JavaScript, any kind of state management or anything, because that's all built into Blazor. So I think we're at the point at the moment where it's still such a new technology. Nobody's really come up with that sort of killer app for it yet. But I think it's only a matter of time before some enterprising dev goes, hey, why don't we use this to send people to the moon? Or so, please don't send people to the moon with Blazor. But, it's only a matter of time, I think. I reckon within the next 6 months, we'll have a killer app that uses it. So far, like all of Microsoft's examples when they're showing it off have been to-do lists and nerd dinner and organizing flights and things like that, where you're literally going to the server, getting some data back, and displaying it. It's essentially CRUD apps is what they've showed off so far. I mean, I'm not trying to dismiss what they've done, and I'm not trying to say that the technology is old hat and it's not very good. It is absolutely amazing. It's just no one's figured out the sort of killer app yet.
Sure. I guess it's a bit like when people finally latched onto HTML5 and the Doom running on HTML5 canvas was absolutely everywhere. Everybody was talking about it and how awesome it was, and everybody sort of went, yeah, but that's cool, but what can I actually do with it? I think we're in that similar space with Blazor at the moment.
Sure, definitely.
And I think from the way that you described the use case of being out in a field and doing stuff, it kind of makes me think that maybe this is a bit more of a grown-up version of progressive web apps, maybe something a little bit more in tune for the .NET community.
Definitely, yeah. I mean, when I was first being told about it, I thought, that's service workers, surely. But then, obviously, you're doing it entirely in .NET, so you don't have to leave the. And I think you've described it as well in this way before as well, James, when you've said, .NET is programming in easy mode. We don't have to leave that sort of comfort blanket of, I don't need to learn JavaScript and the intricacies. And, I mean, let's be honest, there's a lot of weird edge cases with JavaScript where even things like, is 0 a number? Well, in some instances it is, and in some instances it's not. So, you don't have to write reams of code just to protect yourself from a divide by 0 that ends up with a not a number, or a divide by 0 that ends in, -1 or something,
Yeah.
You don't have to do all of that because it's all been taken care of for you by the compiler designers.
Sure. And I'll preface this comment with the fact that I am a .NET developer by day, so please don't be offended. But I think the comment that Jamie's referring to is that I took a look at C++ several years ago and spent a good few hours writing a Hello World application, and after 14 million lines of code, I thought, no, forget this. We'll go back to the pretend, to the world of .NET Core and pretend programming. So I always refer to it as pretend programming, but that's what he's talking about there. So if I want to sort of go out there and get stuck into Blazor, where do I start with making a Blazor app? Do I need to download any special runtimes or anything like that?
So long as you've got .NET Core 2 or greater installed on your machine, you should have a bunch of templates that will allow you to install to run Blazor apps, so to be able to create the Blazor apps. So you shouldn't need any special technology at all other than the .NET Core SDK and presumably some kind of text editor or an IDE or something.
Yeah, all right, cool. So if it's these templates, if it's based on these templates, there must be a specific way to develop these applications. I can't just go and take my current ASP.NET website and go, right, build that as a Blazor app. I guess it won't just work like that.
Yeah, there's a little difference in how There's a few differences in how ASP.NET Core, for instance, or ASP.NET Framework runs compared to Blazor. So let's say in ASP.NET Core, you have a startup class which describes how the web server that ASP.NET Core is going to use is going to sort of bootstrap your whole environment. You configure any services in there, you configure your database stuff in there. In a Blazor app, the key important thing is to do app.useBlazor, and it tells the entirety of .NET Framework, the entirety of .NET Core, hey, this is a Blazor app, and go do the Blazor thing. Don't do the ASP.NET Core thing, because we don't want that. We want Blazor, so go do your Blazor thing. And what will happen is you traditionally have a client and a server application, which is a bit weird because both get loaded into the browser, but the server starts up and serves your client app inside of your browser. So the whole thing is inside your browser. So your server application, although it's in the client, will serve your client application by using that app.useBlazor, and you tell it which startup file to use, and then your Blazor app, the client inside of the client, it gets really confusing at this point, will use standard ASP.NET to start up, and you can dependency inject, and you can use Razor pages, and you can do all those kinds of wonderful things, MVC and Web API and stuff, but inside the browser, which is where it sort of gets a bit weird, because you're like, but I'm doing a web request to something that's inside the browser, so it's not leaving the browser, but it appears in the network tab because it's a web request, but it's going to itself. It gets a bit weird.
Yeah, it's Inception for programmers, I think.
That's exactly it.
So, if these are web apps, and obviously the name infers the Razor views, is it still using the Razor views that we know from MVC?
Sure. Yeah, you can still use Razor, the templating engine, so you can still have an MVC-like view in there. I think the recommendation is to use what are called Razor pages. So if you've ever done ASP.NET web forms, Razor pages are similar to, but not exactly the same as MVC sort of Razor stuff with a view and a model and a controller, in that you have a Razor page which describes how to transform into HTML. So we'll have your HTML tags and a couple of @ with some C# code inside of those, but you'll also have a code behind file which describes all of the functions and methods that will be injected into that Razor view at runtime. So you might have maybe you'll have a button that says, go to the API and get me the next 3 things in the list. So you'll have a button and you'll map that to a function inside of that code behind file. And then when you click the button, the code behind file is fired. The method on that code behind file goes and does its thing. It then returns, and then maybe it changes something in the DOM, maybe it doesn't, maybe it's a post method. So yeah, you still have that Razor system, except that you're recommended to use Razor pages. And what you can do with Razor pages is it works a little bit like Angular and Vue and React, in that you can have components. So you could have an entire Razor page that just describes how a button looks or how a button works. And you can reuse that button all the way through your web app, or you can have a Razor page, Razor component they're called, that describes how a form looks or how the whole page looks. You can go all the way down to individual elements, or you can zoom all the way out and describe your entire page.
Sure. So for those of us that have been doing .NET for a little bit longer than we probably like to admit, it's very much like working back with web forms. But because it's all in the browser, I guess there's a very small delay with postbacks and things.
Well, yeah, I mean, there aren't any postbacks. That's the magic of it. It still uses the routing that MVC uses, but it has this sort of... So they're using Razor pages as kind of a halfway house between full MVC and, the I don't want to say old, but the older technology of postbacks and the that kind of stuff, so you're not having to, it's kind of a halfway house between, and you've got full dependency injection, and even if you're 15 layers deep into a component layout, so if you have that button, you can still dependency inject whatever you need just to run that button. So let's say your button requires a service, so you can dependency inject the service so that when you hit the button, .NET Core will give you the service that you want and call the methods and all that kind of stuff. Or you can, if you are that way inclined, you can dependency inject your DB context into the button for some reason, and you can click the button and drop the database.
Do not do that under any circumstances, anybody out there. I will hunt you down if you do.
Maybe that's a new career path for us two, James. Drop database as a service.
Nice, yeah. Possibly. So, if we've got these views and a lot of the functionality is now written in .NET code, is there still support for writing JavaScript in your app? Can you still use CSS as well?
Sure. Well, like I say, it's still a HTML framework, so yeah, you can still have CSS, and you can even have in one of the latest versions of Blazor, I think it was the version that was released in November. You were able to do templating for CSS as well, so you can apply in the same way that you can with Angular and Vue and React, and I'm sure many other JavaScript frameworks. You can have these components, and the individual components have an individual CSS file that is only applied to those components. You can do the same thing in Blazor, except that because you've got the full power of C# as well, you can alter that CSS before it's applied in the browser. So you can say, oh, but if we only have 3 of these items left, we want to maybe make the background color yellow to make it pop or something. So you can totally do that as well. And with JavaScript, because it's running, because your app is running on top of Mono, which is running on top of JavaScript, you can have full JavaScript interop. So you can have JavaScript files that are loaded into the page, and you can call those JavaScript methods from your Blazor code and the other way around. So you can have an app running that is Blazor, and you go to the JavaScript console and call a method in JavaScript that you've written that say maybe a hello world, that then the JavaScript method calls a component in Blazor and says update your string to say hello world. And then you could do it the other way around as well. So you've got maybe a button in Blazor, you click the button and it needs to do something in JavaScript that isn't mapped to a .NET method or function yet. So maybe let's take for argument's sake dividing a number. Let's say you want to do that in JavaScript land, but you've got a Blazor app. You just literally map the JavaScript code to your button and there's some callbacks and things you need to add. But yeah, it's fully compatible, and you can even use, if you wanted to, you could use jQuery, you can pull in Angular, you can pull in Handlebar.js, whatever it is that you need to pull in, you can still use it because it's still in that HTML environment, and it still has the full backing of JavaScript should you need to use it.
That's really cool, but it made my skin crawl all at the same time. And
yes.
It's a case of, you think you've seen really bad spaghetti code now? If Blazor takes off and becomes mainstream, be prepared for some real awful code to try and dig through. Especially jumping back and forth between JavaScript and C#. That should be that should be very interesting, to put it nicely. Because if you can do it, somebody is going to try. Someone's definitely going to try. You mentioned there that you can actually pull in Angular and React and Vue. Is that something that you would even bother to do? What are there any benefits to pulling in those JavaScript frameworks?
Well, I can imagine that there might be, say you're starting a journey in .NET Core, we'll say, and you're picking up Blazor, and you start to, I can figure out what this means, and I can create a component, I can display it on screen, I can do some stuff, but gee, I wish I knew how to do it like I can in Angular. You could pull that in and have them running side by side. until you're more confident with Blazor, or you get to a point where you're like, actually, I'm not really getting on with Blazor. I'll just switch back to Angular. You don't really have to do very much because you just take out the Blazor stuff and you still have your single page application that is an Angular application. So it's kind of, I feel like it kind of leans towards either side. So it gives you that flexibility to go, actually, I want to have C# in the browser for this one particular thing, or I want to use JavaScript. There might be something that you're doing that requires a lot of processing power or a considerable amount of speed to be able to do it. So why not pull in Blazor and have that whole thing happen in C# or in .NET and have the response sent over to JavaScript so then JavaScript can do whatever it needs to do. Say if you're calculating the Mandelbrot set or the Fibonacci sequence to a million places, that might be quicker to do in C#. So you might pull in a .NET a NuGet package. So that's the other thing as well. Because it's .NET standard, you can just pull in a NuGet package and have that do whatever that package is doing, and then have the response from that package fed into your JavaScript to do whatever it is that your JavaScript was doing with the response.
Nice. Yeah, it definitely does a whole lot of stuff, which is probably the really wrong term to use, and it seems very, very powerful for what you can do with it, and I guess it's going to be a case of, as you mentioned, waiting to see what that killer app is, and I think it's like a lot of these game-changing technologies. You look at them and you think, yeah, that's cool. What can I actually do with this that I can't do now? And it's not until somebody smarter than myself does something and you go, actually, now I get it. Now I know exactly what I can do with this that I couldn't do before and why I would want to do it that way. So I think it's going to be a case of just either suck it and see, get out there and play with it, or wait and see what other people come up with and where it goes. It's definitely an exciting time for .NET. There seems to be a new solution using .NET coming out every week at the moment. It's almost as bad as the next JavaScript framework.
That's it. .NET has become the new JavaScript, I think.
Yeah, you heard it here first. So, one final question before we wrap up the episode, which we always like to ask, is that if the listeners wanted to go and get started with this, have you got any useful tips or links for them to go to and start playing with it themselves?
Sure. Well, the first one I would recommend is Blazor.net, which is, I'm not sure it is run by Microsoft, but you can contribute towards the documentation. It's along the same lines as the new Microsoft documentation is all on GitHub. You can go through to the documentation, make a change, and then your change, once the pull request is completed, will be on the live site. But the Blazor.net talks you through how the whole thing works, what the virtual DOM is, which is something we kind of hinted at but didn't really talk about. That's when I said about the server figuring out the changes and sending a delta through to the client when I covered the server side model. The virtual DOM exists on both the client and the server in the same way that the virtual DOM exists in Angular, and you just say, oh hey, load this thing in, and it will just swap the components out. So how the virtual DOM works, how the render tree works, how to get started with pulling down any packages you need, installing any versions of the software you need. They take you through a couple of sort of example apps and how to use them and how the default template works. So when you do .NET New Blazor, which is almost literally the command you type into your CLI, into your terminal, into your PowerShell, whatever it is you're going to use, it will give you a template that when you hit run, or you type in .NET run, or you hit F5 or whatever it is that you do to start your app, it's a fully working Blazor app. But the Blazor.net documentation talks you through how that entire stack works as well. So you can go, oh, right, yeah, I can see now. I have a working example, and I can look at each line of code and figure out how it all maps across. Whereas things like, the Angular documentation is, come with us on this journey, type this thing in. Right, brilliant, it's broken because you're on Windows and you're using NPM. or things like that. So I would start with Blazor.net definitely, and there are hundreds of apps already out there. Like I say, they're all the cool toy apps, but there's things like I'm pretty sure it's called Bletris. I'll get you a link to it for the show notes. There's PokeBlazor, that's one that I've written, that talks to the Pokemon API entirely in C# and displays whichever Pokemon you search for. There's the example that I used. Again, I'm sort of shilling for myself here, but there's the example I used at Umbraco Fest UK where I showed off how to talk to headless Umbraco. So that's there's that. There's one that is worth looking into, but try not to run it on your machine because it's called Blazor Who Is. That downloads I think 20 megabyte, or the last time I ran it, it downloaded 20 megabytes of DLLs into my browser before it would even start, because this was before the tree shaking was implemented. So it will show you that sort of worst case scenario of, as you were talking about earlier, James, when you said, if I'm loading loads of stuff into the browser, that's going to take a while.
Yeah.
And yes, it will. So that's a good example of how not to do it, because they included, the author of that system included Newtonsoft JSON before the tree shaking happened, so that's 16 megabytes of DLLs straight away, and they were just doing a single JSON.deserialize at some point. So, it's that swings and roundabouts. There are a whole bunch of examples on Steve Sanderson's website. So he's the guy who sort of spearheaded this at Microsoft, and he has a full. I'll get the link for the show notes. He has a full-on technical description of how the entire stack works, and from a let's have a look at how the code behind that you're not even talking to, the code behind that you're talking to works. So there's that as well. I can get you the links for those as well. So they're really good if you want to deep dive into how does Blazor actually run on my browser, or how do I get started. I would try both of those, Blazor.net, and I'll get you the link for Steve Sanderson's technical description of how it all works.
Sure, that'd be great. And as always, it's been a pleasure. So thank you for coming on and talking to us today.
Thank you for having me back again, James. Yeah. It's been a lot of fun.
Yeah, not a problem. And no doubt we'll probably have you back on again to talk about something else that you've decided to really geek out on, probably in the near future. So until then, thanks.
Thank you very much.
And thank you to everyone out there for listening to The Cynical Developer. I'm James Stoddart, and you've been listening to Jamie Taylor talking about Blazor. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help The Cynical Developer to reach more developers around the globe.